Hi and Assalamualaikum. My name is Maizatul Hanin binti Muhammad Khairun from 1DEES1/1. In this video, I will explain my understanding for Lab 9. The title is PCB Layout using Proteus Professional. In this lab, the objective is to construct a complete PCB layout design using Proteus software and understand basic knowledge in designing PCB board. So let's go to the first procedure. The first one is design the circuit diagram using Proteus in figure 1. Figure 1 shows the digital doorbell circuit. This is the circuit that I have designed in Proteus software. Let's simulate this circuit. As you can see, there is no error during this simulation. Now let's move to the next procedure. The next one is list down materials and components in the circuit. Okay, the total component that been used in this design is 43. We have capacitors, resistors, different type of ICs, diodes, connectors, speaker, buzzers, power and ground. Next one is we need to produce double layer PCB layout. For PCB layout, we need to go to Proteus software and then click PCB layout. The size of this layout is 14 cm times 10 cm. This is the complete circuit for PCB layout that I have arranged. Before I arrange the component, this is how it looks. Very miserable. So, from this PCB layout, before that we need to perform electrical check, netlist check and simulation on the circuit. Just now we have done the simulation. Now let's go to electrical rules check. For electrical rules check, it shows if there are several errors found in the circuit connection. In this design, there are several pins not connected to any components, which leads to ERC errors. As you can see, this one not connected to any component, and this one also. Okay, next is netlist report. For netlist report, this is to prevent unexpected errors from occurring, as it serves an extra verification for the design and also ensure that when the manufacturer is completing the electrical test of the circuit board, the process will be accurately testing against the intended design. Lastly is bills of materials report. As I mentioned before, the total component in this design is 43. We have 12 capacitors, 19 resistors, 9 ICs, 1 diode, 1 speaker and 1 connector. Now from the PCB layout, we need to generate the Gerber file which include top copper, bottom copper, top silk, bottom silk, top resist, bottom resist, drill and edge. Don't forget to select mirror and RS274X. Go to Proteus software, PCB layout, click output and generate Gerber files. Click yes. Now it processes the image. Yes. Now select the desired layer. Top copper, bottom copper, top slip, bottom slip, edge, drill. This one need to change to mirror and RS274X. Click OK. This is the Gerber file that we have generated. Okay. To view this file, we need to use viewplot software. First, clear all layers. We can choose let's choose bottom copper first. Okay, this is the image for bottom copper. Clear layer first. Next is bottom solder. This is the image for bottom solder. Let's try top copper. This is how it looks. Next is top silk. This is happen when we open two files, which is top silk and top copper. What happen if we choose to open all files? This will give the same image as in PCB layout in Proteus software. This is the same. The difference is just in view plot. Since we select the mirror, the image is against the original. Okay. Okay, as I mentioned before, for discussion, in PCB layout, we must first specify the size of the circuit. This is to ensure all the components in this design is fit. We use 14 × 10 cm. And then, according to the next step, we need to generate Gerber file. Next is use viewplot software to view each layer of the PCB design. This is important. The copper path need to have appropriate distance to prevent bridging during soldering process that can lead to failure. Okay. As a conclusion, after completing this lab, we are able to construct a complete PCB layout design using Proteus software, also understand basic knowledge in designing PCB board. We must know the size of layout, then perform electrical rules check, netlist to identify errors in the circuit design before proceed to PCB layout. Okay, that's all from me. Thank you for watching.